Hello everyone. So today we are going to solve another interesting problem number 62, unique paths. And the problem says there is a robot on M cross N grid. The robot is initially located at the top left corner, that is grid 0, 0. The robot tries to move to the bottom right, that is grid M minus 1, N minus 1. The robot can only move either down or right at any point. Given the two integer m and n, return the possible number of unique paths that the robot can take to reach the bottom right corner. The test cases are generated so that the answers will be less than 2 raised to 10 raised to 9. Okay, so we are at the top left and we want to go to the bottom right. So, and this is a robot at 0, 1, 2, and this is 0, 1, 2, 3, 4, 5, 6. This is zero indexed grid we have, and we can see that our robot can only move in these two directions, like right. So right, it can take one step, another step. So this is step 1, step 2, step 3, step 4, step 5, and step 6. So in total it can take n minus 1 steps on right. And we see it can go down, so it can move 2 steps, which is basically it can take total of m minus 1 steps on down. So our robot takes total of m plus n minus 2 steps, and it can either go left, it can either go right or bottom. So which is basically m minus, so on the right it can go n minus 1 steps, and or in the bottom it can go m minus 1 steps. So what does that mean is, out of total m plus n minus 2 steps, our robot can only take n minus 1 steps on the right and n minus 1 steps on the right and m minus 1 steps on the bottom. So out of total m plus n minus 2 c, we have to choose n minus 1 or m plus n minus 2 c m minus 1, and these two are basically equal, which is a property of combinations. So we can do this problem via this way, via calculating the factorial. So for I will plug the values for 1. So for m is equal to 3 and n is equals to 7, our m plus n is total is 8c and 2. So 8c2 is factorial 8 upon factorial 2 into factorial 6, which is 8 into 7 by 2, which makes it 28 steps, which is what we are looking for. And we can also observe our robot can move in this direction, like this is, it can take one step, one step, one step, one step, one step, one step on the right, and in bottom it will take one. So to reach here we can come from top or from left. So this make it 2 steps. For this we make it 3 steps. It's for 4, 5, 6, 7, and this makes it 3. Then 3 and 3 becomes 6, 6 and 4 becomes 10, 10 and 5 become 15, and 15 and 6 become 21, and 21 and 7 become 28. So for this second approach, I observe one pattern. So the pattern that I observe is I observe the pattern that my f of I comma j is 1 when my I is equals to 0 and j is equals to 0. I is when we are moving in the rows and j is when we are moving in the columns. Otherwise, it is f of I comma j minus 1 plus f of I minus 1 comma j for all I belongs to 1 to m and j belongs to 1 to n. So basically we are filling this and we are looking for f of m minus 1 comma n minus 1. So what we are basically doing is we are filling this dp array bottom up, and the reason why I say this as bottom up is because we are filling the decision tree of reaching the value of f of m minus 1 and n minus 1 uh, from bottom towards the up. So what we are doing is basically we are here, we want to reach to f of 3, f of 2 comma f and f of 6, and we can come to f of 2 and 6 from f of 1 comma 6 or from f of 2 comma 5, and to reach there we need the sum of both these two. Similarly, to come to f of 1 comma 6 we can come from 0 comma 6, which is this spot, plus we can either come from f of 1 comma 5. So to reach this top, this is the, so we are filling this tree basically from bottom to up. So that's why this TP tabulation is called as bottom up array. So now let's get into the coding part of our approaches, and I'm gonna show you both the approaches of how we can write this combination and the DP tabulation array. So we'll keep all this that we have because that will help us in writing the code. So this will remain here, and this is our tree. Let me make it short, and now let's get into the coding part. Okay, so first I'm going to show you the bottom up approach. So the approach is bottom up, and we are gonna write what we decided. So first we'll declare on DP tabulation. We know that our first 0th index row and 0 index column is going to be 1. So that is what I'm declaring over here. And now we need to start filling. So we say that for I in range M and for J in range N, we need to find DP of I comma I and J, which is we'll get from the summation of previous row and previous column. So dp of I comma j minus 1, and in the end we want to return dp of m minus 1 comma n minus 1, or we can directly write this is the last value, so we can in Python we can write dp of minus 1 comma minus 1. So now let's submit our solution and see how it performs. So okay, so I think we missed like from 1 to n, and we are going from 1 to m. So now, okay, so it has been running properly. Now submit our solution. So it has been accepted and it's running pretty fast and amazing. And the time complexity for this approach is O of m into n, and the space complexity is O of m into n, because we are filling this 2D array. So this is our approach for the first one. And now let's write the second approach. So the second approach, that what we decided is we can do it via the combination way. And to do that, what we need is the combination function. So to get the combination function, we can directly do this from math. We can import combinations. So we can say from math import combination, and that will give us directly the unique combination that we are looking for. So we'll directly do combination of m plus n minus 2 comma m minus 1. So that would also work, or we can directly write with the formula, which is for the factorial. So we can import factorial, and we can do factorial of, which is factorial m plus n minus 2 divided by factorial of m minus 1 into factorial of n minus 1. So this will also give us the same result and same approach. So now let's run this and see how it performs. Oh, so we don't want this p. So here it is factorial. So this has also been running fast, and this is the using the inbuilt methods of the Python language. But what I'm interested in showing you is how we can write this in our own factorial function. So what we'll do is we'll write our own factorial function. We'll name it fact, and now we're going to write that own factorial function of our own. So that would be, so we need define, we are defining our own factorial for any given number n, and we will return this f of n, and we'll start from so this is the function of this is the properties of factorial function, that if the factorial of 0 is 1, and for 1 it is 1 itself, and so and the factorial of any number is given like this. So if I'm looking for to find the factorial of, which I showed that I am looking for factorial of 8. So to find the factorial of 8, we do 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So basically we are multiplying the function with its previous value. So that is what I'm going to write. So we need to define the base case that if I is 0 or I is 1, then we want to return 1. Otherwise, our function, if I is in my cache, then we'll return that cache, and otherwise this will store the factorial definition, which is I into f of I minus 1 into the factorial function, and will return the cache that we have created. So we can directly write this and we'll run this. So it will also give us the same result that we are looking for. And let's submit our code for this approach. So that has been also accepted, and it's pretty fast. And if you don't want to do this whole recursion memorization, then what we can do is we can just remove all this, and we can directly return this output, and we can store all these results for this inside one cache of ours. So what we can do is we can say @cache. So that's how we can do this, and let's submit and see how it performs for this. So that has also been accepted. So this is the multiple approaches for solving this problem. I hope you guys are liking my solution, and please let me know if you have any particular problem request. I would be happy to look, and please like and subscribe to the channel. It keeps me motivated to create more awesome content for you. Thank you. Have a nice day.